And they have CTD, chlorophyll, nutrient data at these locations for both years as well. So it's going to be a really interesting database in addition to the fish counts that were taken. So the protocols that HCRI uses for the data collection is they use what's called an REA, or Rapid Ecological Assessment, as described by Prescott et al. 2004 and Broom et al. 2005. What it involves is, and most of you are probably familiar with these methodologies, and we've talked a bit about them up to now. But basically, you have a photo quadrat, two divers going down, taking a picture of the assemblage that's present. And then for the phycologist perspective, what they do is they take specimens, it could be the turf or large macroalgae, whatever's present, and put it in that particular bag representative of that quadrat. And then it's put in the freezer until someone can analyze it. And of course, then that's where I come in, is that I'm the person that gets to take that bag and defrost it and then spend hours under the microscope and the dissecting scope discovering the diversity of algae that's present. And so again, the nitty-gritty, this is where I spend most of my time, is at the dissecting scope and at the microscope, looking at these algae and trying to identify what they are. And it's been an amazing experience. I've learned a lot. The other aspect of what I'm doing is that for each of these photo quadrats, I'm using CPCE or coral point count with Microsoft extensions to calculate the descent cover of benthic organisms. Steve Coles had talked a little bit about that before, so I won't go into it in too much detail. But we're using 100 points to calculate the percent cover of all the coral, algae, and invertebrates that are present. So under each point that you see represented here, we go through and identify what it is using predetermined buttons that we've established based upon what we've seen from collections and then what's present in the photographs. And it's really nice working at HCRI because you can go next door and there's Jean Kenyon who can tell me, oh, you're like, oh, is this lambada or is this, something else? And she can go through and really help me with the identification. So it's been a really neat collaboration. What have we done so far? Again, I just started this work in July with Peter. And so far, what we have are 317 specimens. That's 317 either herbarium sheets or slides that we've created. So all of the frozen specimens have been analyzed. Yes. And out of that, right now, we have 64 genera represented, which is comprised of 87 species. And of this, about 52% are epiphytes or turf. So there's a lot of diversity of algae present, but a lot of what's there is small stuff. From an algal perspective, one of the most thrilling things that I saw doing this, I had never seen this particular alga before, so it was really exciting when I saw it. It's called the Velia jungermanioides. And it's a very distinctive alga. Peter had never seen it before, and apparently you don't see it very often here in Hawaii. So if you ever see it, be sure to collect it because it's just a joy to look at under the microscope. But it looks like, what would you imagine a dragon's tail would look like? And it has these sort of little blades and these hairs that stick off the ends. And it has a circinate apical meristem at the end, so it's like a fiddlehead on a fern, the way that it grows out from that sort of apical end. So it's a beautiful alga that we had in one single collection. So again, it's amazing the diversity of algae that you can see when you look at it under the microscope. And it's amazing what you can find. Some of the general trends, I'm not going to talk about the CPCE results yet. We're still going through and analyzing those. But from what we've looked at so far, some general trends of what we found is that in that 10 to 20 meter depth range, what we see is that there are abundant Halimeda meadows in these areas of Lanai. And then around area 3, it's very silty and heavily sedimented. And if you look at sites 4, 5, and 6, and again, this is just from the 2004 data, the first year data, we haven't analyzed the second year yet. What we see is that these areas are particularly dominated by Parietes lobata, Parietes compressa, and Montipora capitata assemblages. And so the coral reefs through here tend to be dominated by these types. Upcoming objectives of what we have to do with this project is I'm going to be finishing the CPCE photo quadrat analyses this week. We're going to do statistical analyses using primary software such as a two-way cross NSM to look for the temporal and spatial differences. I'm going to work with Peter and Dr. Abbott on verifying the algae identifications to make sure I haven't been sipping too much fingernail polish fumes when I was making the slides and identifying them. We're going to integrate fish, towboard, and oceanographic databases with the collaborators, again, to take this ecosystem approach in interpreting the data. And we get to write the manuscript on all this information. So all of this we'll have done by December, and look forward to seeing what we find out with the CPC analyzing the data sets and such. But I just want to especially thank Peter Broom, Christine, Risa, and Pam for the support and opportunity. Susie and Chrissy are in Peter's lab, so it's been a joy to work with them there. Genjin Kenyon and Jameson Go for the help dealing with the corals, and Jameson with the oceanographic data. Brian Acano, John Mitchell, Aline, and Emily Krause are the ones who initially collected this data, so I thank them for their fine job of collecting it correctly. And then the websites that I use to get some of this information from. These are some of the freezers of the backlog that Peter has, and there's even an additional one that he's been working on. So it's nice to be able to contribute to a project like this and hack away at the inventory